Hello and welcome to the program. Let's talk about live coral trout. In the year 2000 it was conservatively estimated there was about $10 million worth of live coral trout exported as part of the live fish export. But it did not keep up with demand, so clearly there's room for more product to be exported. So, where's the fish? One of the issues affecting the live coral trout fishery expansion is the occurrence of injury and disease in the fish between capture and processing. Fish showing obvious signs of major stress are immediately sacrificed to obtain fillet or whole dead fish. And the leakage of this product from the high value live market to the lower value fillet market results in significant loss of value in the fishery and a resulting loss of income to all sectors of the industry. As a result of these concerns, the live reef fish industry made a request for research to try and solve these problems of disease and mortality in the live fish trade. In 1997, a grant from FIRDIC, the Fisheries Research and Development Corporation, was awarded to Dr. Trevor Anderson and colleagues at James Cook University. In conjunction with FIRDIC and industry, these researchers investigated sources of stress in coral trout during the catching, handling and holding processes. They tell me this has all been achieved by looking at the blood from live coral trout. Is that right, Trev?
Absolutely, Brett. We went to sea with a number of fishing vessels and took blood from coral trout at various stages of the capture and holding cycle. Within the blood, there are biochemical components which indicate the level of stress in the animal. These need to be isolated from the blood using modern technologies. Some of the indications of stress in coral trout are cortisol, glucose and lactate. These change over time, rising quickly to 30 minutes before recovering if animals are held in good conditions. Stress has been measured under a range of conditions. These include level of oxygen and ammonia in the water, deflation of the swim bladder, the effect of dehookers, and stress at different stocking densities. The outcomes of this research were to identify problem areas and ways in which practices can be improved to minimise stress.
Thanks, Trev. So there we have it. Topics to be covered in this video include handling, dehooking, deflation of swim bladder, fish caught from deep water, water quality, dory tank design, freshwater treatment, stocking densities, feeding regime and seasonal variation. So before we look at the results of the research findings, we need to examine the question, how is stress caused in fish?
They're a waste of bloody time and space.
And is it the same as in humans?
She's cool, she's cool. Here, water.
Put simply, stress in coral trout is produced from biochemical reactions which run out of control when fish are removed from their normal environment and placed in a dory tank. These biochemical reactions produce significant amounts of circulating hormones and sugars in the blood. Increased concentrations of hormones and sugars cause trout to suck large amounts of oxygen from the water. Trout also produce ammonia at a fast rate by vomiting and excreting. This degrades the water quality as ammonia is very toxic to marine animals, causing further stress to the trout and the vicious cycle continues. One of the interesting things we found was that although all trout get stressed, some individuals appear to handle it a lot better than others, much like humans.
Let's have a look at a doryman at work and see if we can identify any practices which may be thought stressful to the trout.
Oh no, there's no water.
Like we said earlier, live trout, not dead. And that's obviously not the right way to do things. So let's have a look now at some of the different things you can do to minimise stress when you're handling trout. One thing we can't avoid is stressing the trout by catching them. A hook in anyone's mouth is bound to cause discomfort and heartache. However, we can avoid stressing them any further once in the boat. Here's how you might do it. The very first thing to do is to make sure there's good clean water in the dory tank before releasing the trout into it. Minimise touching and grabbing the fish as much as you can, as this breaks the protective mucus layer on the fish. Release trout as quickly as possible. Use a de-hooker at all times. The pearling industry in West Australia had a major disease outbreak in the late 70s because they were handling the pearl oysters like bricks. A coral trout's not a brick, so try not to handle it like one. One of the common side effects of quick hauling is swim bladder expansion. If the fish is caught with a distended swim bladder, deflation must be carried out as quickly and efficiently as possible. Deflation is best done while the fish is still on the hook and can be held in an effective and supportive manner. With support, deflation can be achieved by the insertion of a hypodermic needle at the point near the anus. And with practice, you can also deflate the swim bladder underwater. The appropriate needle to use for deflation is the 16-gauge hypodermic needle, and they can be purchased at any chemist. Coral trout are often caught from water greater than 10 metre depth. The research found that if the fish was inactive or dead looking after being hauled from the deep water, it was likely to remain that way. So rather than try to revive it by deflating the swim bladder and placing it in the dory tank, it's better to put it on the ice immediately. Also, if you don't place the trout in the dory tank, it can't pollute the water as it dies.